All right, guys. Picking up where we left off, ready for number 17. Which of the following is a vertical asymptote of secant 1/2x? Now, you can do this in a couple of different ways. One way that I like to do it is, I like to sketch my secant. This is for the regular secant. Alright, so let's make sure everybody's good with that. So how did I sketch my regular secant? I sketched a cosine, put in asymptotes where I cross the axis, right? And that's where I'm undefined. That's where my asymptotes are for the regular secant. Now, what happens with this equation? What happens? Well, all of the x's get divided by a half, which means they get times by 2. So if it was pi over 2, it's now pi. If it was 3 pi over 2, it's now 2 pi, or 3 pi. All right, or either of those answers. D. So D is your answer. Okay, does that make sense to everybody? Which of the following has a vertical asymptote at x over 2? Now, if there's a vertical asymptote at x over 2, then that means it's undefined there. Okay? So let's look at cosecant. We're talking about being undefined at pi over 2. That is the 0.01. The cosecant is the reciprocal of the sine. Is 1 over 1 undefined? 1 over 1? No, that's fine, right? That's 1. So it's not cosecant. What about, well, the rest of them have alterations made. All right, so let's look at the next one. Cosecant 2x. All right, if x is pi over 2, then cosecant 2x will be the cosecant of pi. Would you agree with that? That's here. Is the cosecant undefined at that point right there? Yes. Because what is cosecant? 1 over sine. If sine is 0, 1 over sine is going to be undefined. Vertical asymptotes mean undefined. All right, which of the following has a vertical asymptote at 2? Now remember, if there's nothing, none of the regular pictures has a vertical asymptote at 2. Would you agree with me? The asymptotes are pi over 2 or pi or something like that. So, if we have a vertical asymptote at 2, then something happened to my x values. They had to have been divided by something, and it would have had to have been some version of pi, right, to get rid of that pi. So, it looks to me like my answer is either C or D. Now make sure you're following my logic. A and B have asymptotes, but those asymptotes are at pi numbers, pi over 2, pi, 3 pi over 2. The only way to have a plane 2 is to have gotten rid of the pi, And the only way to do that is to divide by it. So I'm either looking at C or D. Now I happen to have my secant graph up here. If I am doing secant pi x, then I am going to divide all of these by pi. Would you agree? So dividing by pi would give me 1/2, 1, 3/2, and 2. Isn't that what I wanted? Yep. So the answer is C. All right, 20 is another equation, but it's written differently. Do you understand that we're looking at 3 cosecant squared minus 1 equals 3?
You said the last one was C.
Yes. Because 2 pi divided by pi would be 2. Oh, wait, no, it's not. There's no asymptote there. Nope, it's not that. I'm sorry. I need an asymptote, don't I? Let me read the question again. Yeah, vertical asymptote at x equals 2. This does not have an asymptote. This has an asymptote of 1/2 and 3/2. All right, well, hopefully pi over 4 works. If I divide all these by pi over 4, I'll be multiplying them by 4 over pi. There it is, that equals 2, so it is the last one. Thank you, Lauren. It is the last one. I'm looking for asymptotes. I gotta have an asymptote. All right, so now I got this equation right here. Any ideas on how to solve that guy? Add 1, divide by 3, that seems like a good choice. And then maybe square root, plus or minus. So the cosecant equals plus or minus 2 over root 3. Which means the sine equals plus or minus root 3 over 2. Which is what kind of angles? Pi over 3. So pi over, it's plus or minus, so it's all of them. What do you think about that? Is that okay with everybody? No mistakes on that one? Okay. All right, what about the next one? I think I'm going to need a calculator on this one. Let's see. 3.5 cotangent 0.51x equals 0. It says find the zeros. So that means where does it equal 0? Everybody okay? So let's divide by 3.5. And basically, we're wondering, forget this for a second, the cotangent of something has to equal 0. Where does that happen? Where does the cotangent equal 0? Now remember, cotangent is x over y. It doesn't happen here. What about up here? So this in here could be pi over 2. The cotangent of pi over 2 is 0. How about over here? No. How about down here? Yeah. So whatever's inside the parentheses has to be either pi over 2 or 3 pi over 2. Right? But what what's inside the parentheses is 0.51x. So 0.51x equals pi over 2, or 0.51x equals 3 pi over 2. All right, so what are those x values? For one of them, I got 3.08 basically. And I'm supposed to always round to the thousand, so I'll just stick a 0 in there. And then the other one is 9.24. Yeah. Okay, is everybody good at this point? We're not quite done. Because the directions say for problem number 21 that whatever answer you give has to fall in that interval. And 2 pi, remember, is 6 point something. So this guy is too big. He's a legit answer, but he doesn't fit our parameters, so we have to get rid of him. Is that okay with everybody? Lola's yawning. It's all right, Lola. This one will get your attention. This one looks kind of fun and exciting. So 2.1 plus 2.7 secant 3 minus 0.4x, where it equals negative 5. All right, so probably we should subtract negative 7.1 and divide everybody okay with what I've done so far? Is that okay? And 7.1 in the numerator, so I just got rid of the decimals, times them by 10. I don't want to deal with the decimals. Yeah, I don't use a calculator. Now, I don't deal well with secant, so I'm going to say the cosine of this angle is negative 27 over 71, or 2.7 over 7.1. Is that okay? So again, don't let this part bother you right now. The cosine of something is that number. Where will the something be? If the cosine is negative, it will be over here or over here, right? Right? Now, the angles I'm looking for are this one and this one. And both of those are going to hinge on whatever that angle is right there. Okay? So I am going to second cosine 27 divided by 71, and I'm not putting in the negative. Oh shoot, I need to breathe. I got 1.181. This angle right here is 1.181. Remember, when you are finding angles in different quadrants, you need the reference angle. If you put in the negative, you're actually going to get the blue angle. But then you still have to find the pink one. So you need that reference angle right there. On the unit circle, that is like your pi over 3. So you do pi minus pi over 3, pi plus pi over 3. 2 pi over 3, 4 pi over 3. This is like your pi over 3. It's the angle in quadrant 1. It has that cosine. Now you're putting it in quadrant 2, so you will take pi minus 1.181. And the blue angle is 1.961. Is that what you got? That's your blue angle. Now how will I find my pink one? Pi plus 1.181. So my pink one is 4.323. Now, those are not the answers to the question. That's what goes in here. If you take the cosine of 1.961, you will get that number. But that isn't called x. If that was just x, these would be your answers. That is called 3 minus 4x. So 3 minus 4x equals those two numbers. Remember, you are solving for x. So 3 minus 4x equals 1.961, and 3 minus 4x equals 4.323. All right, so let's see who gets the answers out of this. Is it 24? Okay, 1.9 dividing for this one, I got x equal to 2.598. What about you? Did you get that? You're not even going to get that either. Somebody double check it for me. Good. Now I'm doing the other one. And for this one, I got negative 3.3075. Thinking about our directions, what do you think? Are we going to keep both of them, get rid of both of them, keep one? What are we going to do? Keep the first one? Not the second one? Because it's outside of our range. All right, number 23. Let's just go on right now. This one looks easy compared to that. So what's it say? Secant equals 2, which means cosine equals 1/2. That's easy. We ought to be able to get that. Where does the cosine equal 1/2? Cosine 1/2 at pi over 3. 5 pi over 3. All right, would you and your partner try 24 and 25? Second cosine, positive. So you know how when you get a circle, you say it's a pi over 3, but it's in quadrant, whatever. I gotta find the angle that goes with this number. Put it in quadrant 2. Minus pi plus. 24 is all about knowing how to manipulate an equation. And then 25 is giving the range.
We have to multiply by 5. Because in the version of 5, just changes the x. Oh, I was looking at not that. Okay, I think it's Lauren, what do you say?
Alright, what'd you get for number 24? Did you figure it out? B. It's B. Remember, you have to be in factored form to know your phase shift. That's your horizontal translation. And if you're going pi over 2 to the right, then you have to have x minus pi over 2. Regardless of what else you've got, that's what you gotta have. So it's B. Perfect. How about 25? Did you get that one?
B.
Also B. Because we know that the regular secant has a range of negative infinity up to negative 1, and then 1 to positive infinity, because of those parabola things. Putting a 1/2 on the x does not change the range. What does putting the 1/2 on the x do? Changes your asymptotes, but it doesn't change the range. The 5 is what changes the range. Perfect. All right, go ahead and try 26, I guess. Try 26. It looks easy. You and your partner. We'll have somebody put it on the board.
Do you want to do it on the board?
Yeah.
Watching the video, just comment down below, like and subscribe to this channel. We got 12 fiber through actually. Yeah, it is. I did it. I just don't have time. I wonder if anyone else wants to see it. Comment down below, Lauren, what's up? You're watching the video. Mrs. Ford, do you always only write on that side of the board when you're recording? Do you only write on that side of the board when you're recording videos? Oh, it's also mine.
Yes, you can only write on this side. You don't accept this side.
So, oh, we are wrong. It's all the pies. Now we got it right.
All right, let's take a look how guys do, this is very similar to one we did a minute ago, only this is a cosecant. What do you think about this strategy? Does that seem good? Seems perfect. Perfect. Alright. Alright, quickly, let's see if we get one more done. Number 27. So I have written my problems, they equal to each other, subtracted 2 and somehow got -3. I have no idea. Let's start over again. Okay, so I subtracted 2, I got -8. So now I have -80 over 31. Alright, so at least I'm in the right one. Alright, so I subtracted 2, that was a -6, right? Yep. Divided by 3.1, I multiplied by 10 to give me 80 over 31. It can be 8 over 3.1, it doesn't matter. But it is negative. Now, I am not even worried about what this is yet. I worry about that last. Right now what I'm worried about is, what angle has that tangent? Well, I don't know, but I know whatever it is, it's in quadrants 2 and 4 because it's negative. So I'm just going to go to my calculator and I'm going to second tangent 31 divided by 80. And I know this angle is 0.370. The angle that has 31 over 80, that ratio is 0.370. But I gotta put it in quadrant 2 and 4. So what will the quadrant 2 angle be? Pi minus that. So that's 2.772. And then what will the one all the way around in quadrant 4 be? 2 pi minus. And I got 5.914. Alright, is everybody with me so far? Don't get bogged down in the name of the angle. You just know whatever that is, it's in quadrant 2 or quadrant 4. And in fact, this is what it is. So, 0.3x plus 5 has to equal 2.772. 0.3x plus 5 has to equal 5.914. And now I can solve for -7.427. Double check that, is that right? And then 3.047. So keeping in mind what the parameters are for the problem, I'm going to throw this one out, right? But this one is, okay. All right, now you got all kinds of review. You have some in your notes packet. I gave you another little thing the other day. We haven't finished all of these yet. All kinds of review. No, what we're doing tomorrow is you are coming to me with questions that you have found as you have been reviewing. Okay? That's what we're doing tomorrow.
Bye guys, thanks for listening.